Hello and welcome back to another video tutorial. In this video, we will show how to build a tic-tac-toe game using Java JTable. This requires basic understanding of Java array lists, custom JTable cell renderer, image animation, and mouse events. Watch my other videos explaining all of that, as I will not go into details in this video. So let's start. We basically need only one file with two nested classes for this game. The inner nested class consists of extending the default JTable cell render, and as you can see, there is not much inside it. We just defined a custom background color and a border of the table cells as a new default. The main class is our frame, of course, and implements action listener and mouse listener interfaces. We define our components that we need: a JTable for the tic-tac-toe game area, a panel, a restart button, and a label to display player's turn and the winner. We create two objects of the inner class for custom cell renderer. One is the default for all table cells and will remain untouched, and the other will be used to draw icons and then apply it to the cells that are clicked. This section is for breaking our two GIF images and store them the frames in their respective array list. Watch my videos on how to break a GIF image into frames and how to pause GIF image and animation. We need a timer to animate the frames, of course. We also need a 3x3 two-dimension static image icon list with initial null values and an empty static list to pass into the JTable row data and header. In the constructor, we define the properties of our window. We call this method that we defined below that takes a GIF file, breaks it, and stores the frames in the array list. We construct our components, set the properties for the JTable, and add them to our window frame. A method to animate the frames is needed. We define animateTic that takes four parameters: two of type integer that represent the row and column, another of type ArrayList containing the extracted GIF frames, and the last parameter of type string, which is a descriptor for the image icons, so we can compare the similarities of icons to identify the winner. We construct the timer in this method. Basically, when we click on a cell, as long as that cell is empty and doesn't have an icon drawn into it already, we loop through the array list of icons at rate of 20 milliseconds for each icon. When the last image is reached, we stop the timer and therefore the animation. The animateTic method is triggered by a mouse event. When we press the mouse, we first verify that the cell at row and column returned by the cursor is empty, and the tick index variable has a value of 0, which means that there is no animation yet, or the previous one finished and the timer is reset. We have an additional variable of type integer starting at 0 and incrementing by 1 unit when mouse is pressed. If exceeds 1, we go back to 0 again. If O or X variable equals 0, animate the circle icon into the cell at row and column returned by mouse press. If the value is 1, we draw the X animation into that cell. We also display whose turn it is in the label. To actually draw icons into the cells, we need to override cell renderer method in the JTable body. The first custom renderer is returned by defaulted for all cells. If the two-dimensional array list have non-null values, then we set the second custom renderer for the corresponding cells and draw their respective icons into them. To check for the winner or a draw, we added multiple if statements in the animation method that verify all rows and all columns after the timer stops. Any row or column that is not null and with the same image descriptors wins. Anything else while all cells are not null, the game is a draw. If there is a winner, we remove the mouse listener from the JTable. We are no longer able to click or press the cell to draw icons until the game restarts. To restart the game, we click the button Restart, which erases the icons from the table cells and restores everything to their original values and reattaches mouse listener to the JTable. After that, we compile our code to run it to test the game. And it seems to work smoothly. Thanks for watching and goodbye.